We all think we know what air conditioning does, right? It makes a hot room cold. Simple. But that's kind of like saying a master chef just makes food hot. There's this whole fascinating science behind creating true comfort. And today, we're going to pull back that curtain and see how it all really works. So let me ask you this. Have you ever walked into an air-conditioned room and it felt cold, sure, but also kind of clammy and just not great? And then you've been in other rooms that just feel perfectly crisp and dry and refreshing. What's the deal with that? Well, the real difference is way more interesting than you'd probably guess. And that feeling, that difference, it gets us right to our first big idea. Great air conditioning is about so much more than just blowing cold air around. To really get it, we have to look at what it's actually trying to do. Turns out, in our modern world, air conditioning is really trying to accomplish one of two very different but equally important goals. And this slide just lays it out perfectly. On one side, you've got air conditioning for comfort. That's what we all know. The whole point is to create an artificial climate that's healthy and comfortable for us, for people. But then you look at the other side and you see industrial air conditioning, and that is a whole different ballgame. It's all about absolute precision, creating the exact climate you need to make something, whether that's a microchip, a medicine, or a car. Two totally different missions. For today, we're going to focus on the human side of things. And to make us truly comfortable, engineers have to dive into the science of what they call the comfort zone. And check this out. This chart shows you exactly what that zone looks like. See, it's not about hitting one single perfect temperature. You've got temperature going up and down and relative humidity going left and right. True comfort is actually this whole big boxed-in area. It's a balance between the two. You might feel great at 26 degrees if the humidity is super low, or just as great at 22 degrees if it's a bit higher. It's a window, not just a single point. Yeah, think of it like this. If the air gets too dry, way over on the left of that chart, your skin and throat can get irritated. But if it's too damp, way over on the right, it feels sticky and gross, mostly because your body can't cool itself down by sweating properly. So that sweet spot, right there in the middle, that's where our bodies can just chill, literally, with the least amount of stress. And here's the key. This whole comfort zone thing exists because of our own biology. Our bodies are always working to stay right around 37 degrees Celsius. We're constantly giving off heat to the air around us. The comfort zone is simply the conditions where that whole process, that heat exchange, happens totally effortlessly. Okay, so if you're an engineer trying to create that perfect zone for people, you can't just be guessing. You need a really precise language to describe and measure the air you're working with, which brings us to what we could call the language of air. This is like rule number one in engineering, right? You can't control what you can't measure. And the science of measuring the properties of moist air has a name. It's called psychrometry. It's the dictionary engineers use to build our comfort. So let's learn a couple of key words from that dictionary. First up is the one we all know and love, dry bulb temperature. It's just the temperature, what you read on a normal thermometer. Simple as that. It's our starting point. Now, things get a little more interesting with this one, wet bulb temperature. This tells you the lowest temperature the air can get to just by evaporating water. It's a measure of both heat and humidity. So if the wet bulb temperature is low, it means the air is really dry and can soak up a lot of moisture, which is exactly why sweating cools you down so well on a dry day. Next, we've got relative humidity. You hear this one on the weather report all the time. It's just a percentage telling you how full the air is with water vapor. So, 100% relative humidity, that's basically fog. The air literally cannot hold one more drop of moisture. And finally, the dew point. This one's actually super intuitive. It's the exact temperature where the invisible water vapor in the air gives up and turns back into liquid water. You know how a cold can of soda sweats on a summer day? That's the dew point in action. The surface of the can is colder than the dew point, so it forces the air right next to it to drop its moisture all over the can. All right, so we've got all these different ways to measure air. Dry bulb, wet bulb, dew point, humidity. They seem like a random list, but they're not. They are all deeply connected. And engineers have this incredible tool that puts all those connections on one page. It's like their secret map. And that's the thing you gotta understand. These aren't just four separate facts about the air. They're all linked together, mathematically. If you change one, all the others are affected. And you can see how they all dance together on one master chart. And here it is, the psychrometric chart. Now, okay, don't get scared off by all the crazy lines. Think of this thing as the Rosetta Stone of air. It is the single most important tool for designing an air conditioning system. It has every property of air and shows how they all relate to each other in one single diagram. It's amazing.
And here is why it's so powerful. You don't have to measure everything. If an engineer knows just two things about the air, let's say the regular temperature and the relative humidity, they can find that exact spot on this map. And from that one spot, they can read off everything else, the wet bulb temp, the dew point, the whole shebang. It's an unbelievably useful tool.
Okay, I know that was a lot of science. I get it. But it all comes together right now because we have to connect all this theory back to how you actually feel in a room. We got to talk about why this matters.
Because understanding all this science, it explains that feeling we talked about at the very beginning. It's the real difference between an AC that just makes a room feel cold and one that makes it feel truly, genuinely great. When a system is designed the right way, it's not just dropping the temperature. It's also pulling out the perfect amount of humidity, landing you smack dab in the middle of that comfort zone on the chart. That's the secret sauce.
So, what's the big takeaway here? Well, first, remember that AC is doing one of two jobs: keeping us humans comfortable or keeping industrial processes super precise. For us, that comfort isn't just a number on the thermostat. It's that perfect balance of temperature and humidity, that comfort zone. And to get us there, engineers use the special language of psychrometry and their secret weapon, the psychrometric chart, to build systems that don't just feel cold, they feel right.
Which leaves me with one final question for you. Now that you know that creating real comfort is this delicate dance between temperature and humidity, now that you know it's not just about hitting a target number, are you ever going to blindly trust that auto button again? Or are you going to start thinking about the air around you in a whole new way?